Hello children, as you all know that in previous video we have started with our first chapter, that is sets. Okay, we have seen what is the definition of set. Yes, what was a set? It is a well defined collection of objects. Okay, then what we have seen was your sets always are denoted by capital letters. Okay, and the elements will be denoted by your small letters. But you have an exceptional case. Now, yesterday while doing the problems, you might have seen. Okay, if you have the word it has given as school, if it is written in a capital letter, the same whatever is given that should be written. Okay, you can write that elements as capital letters, no problem. But when you are writing it as a set builder form, so you'll be writing that x such that, so in that case, that element should be strictly written in small letters. Is that clear? So now in this videos, we are going to see types of sets. Okay? So there are different types of sets. First is empty sets, then finite and infinite sets, equal sets, subset, power set and universal set. In this video, we'll be just dealing with empty sets, finite and infinite sets and also equal sets. Okay, so let's start with our types of sets. So the name itself says what it is, the empty set. Empty means what? Nothing is there. So a set which contains nothing, that is no element is there in that set. Such set is called as an empty set. That means what? See what it is, a set which does not contains any element is called empty set or null set, or the other name for empty set is what? Void set. So what are the three different names? Null set, empty set or void set. Okay, so the set which does not contains any element is called an empty set. Empty set, it is denoted by the symbol, either by this symbol, this is called as phi. Okay, this symbol is called as phi, or you can just simply draw curly brackets which contains nothing. Okay, so when you write such thing, that is nothing but an empty set. Okay, so what is this symbol? It is an empty set. Okay, that is called as phi, or you can say that it is an empty set, or simply just draw the curly brackets. That also means it is an empty set. Now see what is the example given here. Suppose if R is a set such that it contains, see how it is given, x such that 1 less than x is less than 2, where x is a natural number. Okay, so if I am writing the elements of the set R, how could I write here? Now it contains x such that x is an element between 1 and 2. But again, what is the condition given? X is a natural number. We all know that the natural numbers are what? 1, 2, 3 and so on. So is there any natural number between 1 and 2? No, we don't have. Okay? And hence, what we can say, R is an empty set. Okay? That means simply I can write it as R equal to, yes, just write here 2 curly brackets. That will be an empty set. Or I can write just R equal to phi. Okay, that is phi. So that is nothing but an empty set. Is that clear? Now see here, this is the example that we have taken first. Now see the second one. Second is B is equal to, it contains which elements? It contains x such that x square minus 2 is 0 and x is a rational number. Okay. Now is it given x square minus 2 equal to 0 where x is a rational number? Now, what can we say? B is empty set because the equation x square minus 2 equal to 0 is not satisfied by any rational number of x, rational value of x. Yes, suppose if I have it as, yes, see, you know in your 10th standard and all, x square minus 2 it is equal to 0. Okay, so may I write it as x square is equal to 2. So x will be equal to plus or minus root 2. Okay, but whether root 2 is it a rational number? No. That means the only numbers which satisfy this equation are which numbers? Plus or minus root 2. But root 2 is not a rational number. And hence what we can say is that B set is nothing but an empty set, or just write it as phi. Is that clear? Okay. Now see the next one. C1. Your C is, it contains x such that x is an even prime number greater than 2. Okay. Now even prime number. In your lower class, you have already studied that only even prime number is which number? It is only 2. You don't have any other even number which is a prime. So C, in that definition it was given that x, it contains x such that it is an even prime number greater than 2. Okay. So no number will satisfy such property. Okay. And hence your C set is an empty set. Is that clear? Okay. Now see the next. It contains what? It contains your D set. It contains x such that x square is equal to 4 where x is an odd number. See what is your D set given? It contains x such that x square is equal to 4 where x is an odd number. Okay. If I take any odd number, suppose if it is 3. Okay. So will I get square of that 3? It will be 4. I won't get. Okay. So whether the condition is what? That condition was x square equal to 4 where x is a odd number. If I find the value of x it is plus or minus 2. Okay. I'll be getting it as x as plus or minus 2. But here what it is? X should be odd. So whether that x equal to plus or minus 2, but whether 2 is your odd number, it is not an odd, it is an even number. So I don't have any numbers, I don't have any odd numbers where this property is satisfied. And hence what we can say is your D set also is an empty set. Hope this empty set, is it clear to you? Okay. Now, so whether all the 4 questions are clear? Okay. Now see the next type of set, that is your finite and infinite set. Again by the definition, finite. From your 7th standard, 8th standard, you have come across finite, infinite. Yes, what is a finite set? Finite set, that means we will be able to count. Okay, it is a, we can say that it consists of definite number of elements. Okay, that means I will be able to tell what is the number, total number I can tell. Okay, so that will be what? A finite. Now suppose if I am saying the population of India, is it a finite or infinite? Yes, it is a finite. Okay, even though it is a large number, but it is a finite because if you you may be knowing that every 10 years census is done. Okay, so census is what you do through census. From that government authorities goes to each house and they see how many people are there in each family. Okay, so there they note down how many people are there. So when we can combine each and every census from each district, state, okay, then we can know what is the actual population of India. Okay, so even though you may think that it is a very large quantity, but no, it is a finite set, because that is a definite, that number will be a definite. Okay, if it is not, it will be what? It will be an infinite. Now suppose if I am saying, if you have it as set of natural numbers, set of natural numbers, my least natural number I know it is 1. But can you guess what is the largest natural number? No, I cannot. Because if I say 1 million, the other one can say it is 1 trillion. Yes, or the other can say it is 100 trillion, and so on. That means I don't know what is the last number. I cannot guess what is the last number. So such sets are called as infinite set. Okay, so finite set is what? A set which is empty or consists of definite number of elements. Why is it mentioned here empty? Now suppose if A is an empty set, okay, that empty set, that means it does not contain anything. Okay, but does not contain anything, that set also it is considered as what? A finite set. So what can we say is, every empty set is finite. Okay, every empty set is a finite set. Is that clear? Now see, what are the examples here they have given? Let W be the set of days of the week, then W is finite. Now W is the set of days of the week. That means what and all I'll be having? Here I'll be having Monday, yes, Tuesday, Wednesday, Thursday, Friday, and Saturday. Yes, is there any other day? That means I have that 7 days. Okay, so that will be a finite set. Okay, next is SB, the set of solutions of the equation x square minus 16. How to find the solution? Finding solution means finding the value of x. So x square minus 16 is equal to 0. That means, may I write x square is equal to 16? Yes. That means what is the value of x will I get? It will be plus or minus 4. That means either x is positive 4 or x is negative 4. And hence I have what? A definite number. Only two solutions I have. No other solutions I will be having. So such numbers, it will be what? The set which contains x square minus 16 equal to 0. It will be a finite set. Okay. Now see the third one. Let G be the set of points on a line. We know that a line is what? It is the collection of infinitely many points. Okay, that means if I draw such a line, in that line you have infinitely many points hidden. Okay, so its collection, it is nothing but here infinite set. Okay, the set G be the set of points on a line, it will be set of infinite set. Okay, suppose if I say that A is a set, okay, A is a set of the lines passing through a single point. Suppose this is a point. Now set of all the lines passing through this. We have already seen that through a single point, how many lines do pass? There are infinitely many lines. Okay, I can draw like this, like this. So I can draw infinitely many lines passing through one point. So in that case, the set will be an infinite set. Now suppose if B is a set of lines, number of lines passing through two distinct points. Okay, that means this and this are 2 points. I have to check how many lines can I draw passing through these 2 points. Yes, we know that there is only one line. We can say it is a unique line. Unique means one and only one line passing through two distinct points. So the set B, it will be an finite set. Okay, so whether you're finite, infinite, that it is clear. The first part is very easy to understand. This chapter is itself an easy chapter. Okay, now see, for example, if it is given 1, 2, 3 and so on, it is a set of natural numbers. Now we have seen that roasted form. Roasted form was what? If I am able to list out the elements, that is nothing but your roasted form. Okay, but whether set of natural numbers, set of integers, whole numbers, real numbers, do they have a finite number? Can I write all the numbers in that set? I cannot. So what to do is just write it as 1, 2, 3. The same pattern will be followed. So 1, 2, 3 and just give that 3 dots. Okay, it is enough to give that 3 dots. Okay, so the next number it will be 4, 5, 6 and so on. That 3 dots, it indicates that the given set is an infinite set. Okay, so what we can have is here 1, 3, 5, 7 is the set of odd natural numbers. Again, this is a set of integers. All they are what? Infinite set. So all infinite sets cannot be described in roster form. For example, set of real numbers cannot be described in this form because elements of this set do not follow any particular pattern. Okay, because a real number set, I can just write it as what? I can write that set A as x such that x belongs to R. Okay, R is a set of real numbers. So just I can write in this way. I cannot write set of real numbers in roster form. I cannot list out because your real number set is collection of what? It is collection of all your rationals and irrational numbers. Okay, you can write your integer set, whole numbers, your natural numbers in your roster form, but set of rational numbers as well as your real numbers cannot be listed like this. Okay, because they at least I can say that real numbers, rational numbers, they cannot. Okay, because same pattern won't be followed. Okay, just I have to write it in set builder form. The same thing for your rational numbers, you'll be having it as, suppose if P is a set of rational numbers, I can write it as x such that x belongs to Q, capital Q. Okay, or how can I write a rational number? It is of the form P by Q, where P and Q are integers but Q is not equal to 0. Is that clear? So this set of rational numbers also I cannot write in the listed form or your roster method. Okay, hope this is clear to you. Okay, now we'll see some problems here. State which of the following sets are finite or infinite sets. See what it is. The first set, it contains elements x belonging to n. N means what? A natural number. And x minus 1 into x minus 2, it is equal to 0. Okay. So Suppose if that given set I'm writing as A. So what it is given? A contains, yes, it is given that x belongs to what? Natural number, and x minus 1 into x minus 2, it is equal to 0. So I have to write only numbers which are natural numbers and which satisfy this given condition. Okay. So how to find the value of x? If x minus 1 into x minus 2 is equal to 0, can I say that x is equal to 1 or x is equal to 2? Okay. In this case, whether 1 and 2 are natural numbers? Yes. So, whether my A contains 1, comma 2. Okay. So, how many elements do I have? 2 elements. So, is it a finite or infinite? Finite set. Okay. So, this completed. Next. Now the next set, it contains x such that x is a natural number and x square is equal to 4. Okay, that means I have to find the values of x which will satisfy x square equal to 4 and x is a natural number. So what is given here? X square, it is equal to 4. That means x will be equal to what? It is plus or minus 2. But according to the question, it contains that x is a natural number. Okay, so whether that set P, it contains a single element, that is 2, because minus 2 is not a natural number. Okay, so again this set, it has only one element and hence it is your finite set. Clear? Next again, x belongs to natural number where 2x minus 1 is equal to 0. Again I have to find the value of x. So 2x minus 1 equal to 0, that means what? 2x will be equal to 1 and x will be equal to 1 by 2. Value of x is 1 by 2, which will satisfy this given condition. Okay. Now in this case, whether x is my natural number, the value which I have got? No, it's not. It is 1 by 2 I have got. Okay. That means this given set, suppose this set I am writing it as B, which how many elements will it contain? I have value of x only as 1 by 2, but 1 by 2 is not a natural number. So the set B, it contains no element. That means the set B is an empty set. So whether empty set is finite or infinite, we all know that every empty set is a finite set. So for this, you'll be getting the answer as empty set, and empty set is a finite set. The next is x such that x is a natural number and x is a prime. Okay. Now, which is the least prime? We know it is a 2. Then the next prime 3, 5. Next I can have 7, 11, 13 and so on. Okay. Numbers are infinite. That means primes also will be infinite. So can I just write that 3 dots? Okay. I don't know which is the largest prime. Clear? And hence the fourth set, it will be an infinite set. Next is x is a natural number and x is odd. X is natural number and x is odd. That means natural number which is the least natural number which is odd, 1. So next 3, 5, 7. Again I have many numbers which I don't know which will be the largest. So I'll be just writing dot dot dot. So that will be an infinite set. Hope this is clear to you. Okay, finite and infinite sets. Okay, this is the explanation what we have done.